Hey guys, Miss Duffy here. So it's my understanding this is everybody's favorite unit, including mine. So I think this is going to go pretty quick. I'm just going to cover a couple of things, which include feedback for your FRQ, number one, and the densities and the demographic transition model. So here we go. Okay, now reflecting really quick back on FRQ number one, why was part B stage 5? That was the most missed part of the FRQ. I think only a couple of you got it, which is amazing. Guys, it was not designed to be a trick question. It is where you faulted to use the stimulus. And the stimulus for that part was this chart right here, the epidemiological transition. And if you really looked closely, you could see the answer was right in front of your face. Many of you just tapped into background knowledge, which is great, but said it was stage 2. It's actually obviously stage 5. And the reason for that is because of where my red arrow is pointing there. It's diseases that are resurging because of globalization, which we don't have in stage 2. We're not in stage 2. Okay, I hope that makes sense to everybody. Okay, now moving on. Many of you noted that you needed clarification on the 3 different types of densities. We're going to go over those in just a second, but let's back up for a minute. This unit talks about demographics, and an easy way to remember what that exactly means is demo is Greek for meaning people, and graph is Greek for meaning describe. So when we study demographics, we're essentially looking at things like the demographic transition model. We're looking at population pyramids, and all those demographics are births, aging, deaths, and you even have an aspect of migration. Okay, when looking at demography, we also look at distribution and density. Just make sure you quickly know the difference between those. Distribution is where people are in the world. And this is where we do our 4-level map analysis over and over and over. We see different patterns, okay? However, density is how many people are in a particular area. And that is equivalent to a population density. That is the number of individuals divided by the unit area. Okay, so here we go. There are essentially 3 types of densities. Arithmetic, well, not to confuse you, but that means the exact same as population density. That is people divided by land. That's it. Think of arithmetic as just basic arithmetic, okay? People divided by land. Okay, the next is kind of a step up. It's the physiological density. That is where you divide the people of a given area by the arable land in that area. Okay, arable land is just land that is farmable. Okay, and then agricultural density is pretty easy to remember. That's where you're taking a given area of land and it's the farmers in that area divided by the arable land. Okay, again, those are your 3 types of density. Okay, let's get into it. So you're probably thinking, great, why do I have to know 3 densities? It's so confusing, it doesn't make sense. What's even the purpose? Well, I'm about to tell you. So let's look at arithmetic density. All this is population density map of the world. Quickly, you can see the most populated areas are like India, Italy, really, really simple. The reason geographers need to study this with the other 2 densities is to make predictions. All right, now look at this map. This is the physiological density. See how it's changed. You see your most dense areas in different places now. Remember, this is the people divided by arable land that's farmable, okay? The reason this is so important, these 2 different densities, arithmetic and physiological densities, geographers study these to understand the capacity of the land to be able to yield enough food for the needs of the people in that area. So when we talk about things like carrying capacity, geographers have to make predictions if there is going to be enough resources for the people in that given area. Okay, and then here we have the agricultural density. Again, we see different areas with more density from even the previous 2 slides. Remember, agricultural density is a ratio of the number of farmers to the amount of arable land. So we are dividing farmers by arable or farmable land here. Now, the reason that this is so important is because you can have 2 countries that have similar physiological densities, but they could produce significantly different amounts of food because of different economic conditions in that country. So an example of where this happens is, let's look at the Netherlands versus India. Okay, here's kind of a blown up picture of their physiological densities. Okay, remember this is the amount of people per arable land. So we see that the Netherlands has a much higher physiological density. Here, what do you see change? Now you see, if we do the agricultural density, India is much higher in farmers per arable land than the Netherlands. Okay, so what? Why does this all matter? Well, let's use Egypt for a quick example. There is a huge difference between Egypt's population density and their physiological density. And again, this is where geographers are going to compare the two to predict their carrying capacity, their resources, and what that area can yield enough food for the people. So obviously, Egypt is not going to be ideal for arable land, which goes to show you why 95% of Egyptians are going to live near the Nile. Okay, hope that makes sense. We're going to move on to the demographic transition model. All right, next is standard 2.5, the DTM. What I've done in these slides is I've shuffled them out of order to see if you can recognize each stage. Okay, here we go. So indicating that the green line really quick is our birth rates, the red line is our death rates, and the black line is our natural increase. You can also use the hint at the bottom with the population pyramid. That is definitely a tree. Anybody got it figured out yet? Let me give you some hints. So we obviously see the birth rates dropping. We see a decline in our death rates. We see a pretty moderate natural increase. What part of the epidemiological transition in this stage are we in? We start to see degenerative diseases such as cancer, diabetes. What are women roles here? You start to see more women going to school and getting careers. Any guesses? Did you guys get it? It is stage 3. Late expanding, an example of stage 3 would be India. All right, here we go. Next stage. Any ideas? Okay, we see a high crude birth rate, a declining death rate, very declining, and then we see a very high natural increase. We definitely see a pyramid shape at the bottom, which is a tree. Where's our epidemiological transition? This is where we see receding pandemics. As far as our gender roles, we see that children are like a sign of status and old age insurance. And this was stage 2, and our current example would be Ethiopia for that stage. Did you guys get that one? Okay, next one. What about this? We see the crude birth rates are very low. We see also a very low crude death rate, and we see our natural increase at 0. Whoa, any guesses here? Our epidemiological transition is where we actually have delayed degenerative diseases, so things like cancer, heart disease, we can delay those with our advancement in medicine. And then our gender roles, we see where kids are seen as an expense and women are seeking careers. We also have a lot of family planning. Any guesses? Okay, this is stage 4, and the United Kingdom would be an example of this, also the United States. All right, next one, this one should be easy. What do we have here? What's going on with those birth rates and death rates? They're both really, really high. You can see them squiggling back and forth at the top. We have actually a very stable natural increase. Where's our epidemiological transition model? We see that with things like famine, pestilence, and our gender roles. We also see a very strong difference in our gender roles. And look at that population pyramid down there. Woof. All right, this was stage 1. You all should have gotten that. Remember, we don't have any countries in this stage. However, we do have a few indigenous groups around the world that would be in stage 1. All right, last stage, you guys should be able to get this. What do we have going on here? We see these dashed lines that are indicating predictions, so that should give you a huge hint. We have a very low CBR, an increasing CDR. So this is a situation where you're having more people die than babies being born, which gives us a decline in the natural increase. In fact, in the epidemiological transition model, remember this goes back to your FRQ number 1, this is an evolutionary stage where you are having infectious disease microbes are evolving and changing in response to environmental pressures. We are having developed new resistance to drugs and insecticides. So antibiotics aren't always working. This is why we're having to find a new cure or vaccine for COVID. What's going on with women? Women are definitely in the workforce. You have women marrying later, and it is not uncommon for this stage of not having kids at all. So you should have been able to get this one. This was stage 5. And example countries would be Russia, Germany, and Japan. So I put this in your weekly review. I would definitely have this available and in front of you during the AP exam. You probably don't need to memorize them if you have access to this copy. All right, I know it's fun to talk about demographics, but please don't forget about our migration models and theories. Zelinsky is actually part of the transition model. The demographic transition model does play a role. Like, for example, traditional stage 1 is where you have little migration. You only have people moving around that are nomadic. For example, stage 2 is where you have more people moving from the countryside to the cities, rural to urban, and so forth. So don't forget about that one. Another theory we covered in class, remember, was Lee's push and pull theory. Don't overcomplicate that. That is just reasons people are pushed out of a place or pulled into a place, and don't forget about intervening obstacles. And then last, maybe refresh your memory with Ravenstein's laws. These are the 9 laws of migration, and where we see things like most migrants are traveling short distances, most people migrating are going to be young males, and so forth. So don't forget about those. All right, guys, that's it. I'm going to leave you with one of our famous memories from our class. Do it for Denmark, do it for mom. See you guys. Bye.